Next problem. Obtain the terms up to z cube. Obtain the terms up to z cube in the Taylor series. In the Taylor series expansion. In the Taylor series expansion of f of z equal to z square plus sine square z by 1 minus cos z. 1 minus cos z. About the point z equal to 0. Find the radius of convergence. Find the radius of convergence. Is voice is clear?
Yes, sir.
Yes, sir.
Yeah. Now see. See, this problem is different. Observe the function is f of z equal to z square plus sine square z upon 1 minus cosine z. 1 minus cosine z. And what is the point z equal to 0? See, Taylor series, about what point I have to calculate? Z equal to 0 I have to calculate, right? Okay. Now when I put z equal to 0 in this function, observe this, z equal to 0 in this function, what is this? 0 and sine 0 0, cos 0 1, 1 minus 1 0. So 0 by 0 form you will get. 0 by 0 form you will get. See, this is the behavior of this function. At the point z equal to 0, where we have to find the Taylor series expansion, the function f of z is having indeterminate form. Then what we have to do? We have to apply L'Hospital rule. We have to apply L'Hospital rule to find its value at z equal to 0, right? But here we need only the series expansion, Taylor series expansion. Now, see, you know sin x expansion. What is the sin x expansion? We have Taylor series. We have Taylor series of sin z and cosine z about z equal to 0, nothing but Maclaurin series. As what is the first one? Sin z expansion, z minus z cube by 3 factorial plus z power 5 by 5 factorial and so on. And what about cosine z expansion? 1 minus z square by factorial 2 plus z power 4 by factorial 4 minus and so on. Okay. And how to calculate this one? Just roughly, for example, f of z equal to sin z. I will tell for sin z. Then what is the f dash z? Okay, let me write clearly. How to calculate these expansions? F of z equal to sin z. That implies what is f of 0? 0. What is f dash z? Cosine z. What is f dash 0? 1. What is f double dash z? Minus sin z. What is f double dash 0? That is 0. What is f triple derivative? This is minus cosine z. So what is f triple derivative 0? Negative 1 and so on. And what is the series expansion formula about z equal to 0? F of 0 plus z into f dash 0, right? Plus z square by factorial 2 f double dash 0 plus z cube by factorial 3 f triple dash 0. You know, this is Maclaurin series. About point z equal 0 means Maclaurin series. Therefore, what is this becomes? This is sin z equal to, first one is 0, second one z, and what is f dash? This is cos z means 1 plus z square by factorial 2. This is 0. Next plus z cube by factorial 3 f triple double triple dash is negative 1, right? So what I'm getting clearly, z minus z cube by 3 factorial, and the next term will be z power 5 by 5 factorial. Similarly, you can find cosine z. And see the function. In the function, what is this? Is not sin z. Sin square z is there. So let me find sin square z first. Sin square z is nothing but, what is this? Z minus z cube by 3 factorial, z power 5 by 5 factorial and so on whole square, and so on whole square. So a square plus b square. Let me write. Okay, a square plus b square. B square means z power 6 by 3 factorial whole square. Next z power 10. No need. 2ab term. What is the 2ab term? 2a into b term. Z power 5 by 3 factorial. Right. Let me write another one. 2ac term. 2ac term. 2ab is over. Next 2ac term. 2a value and c value like this. So I'm writing some powers only. Okay. So what is this? Is sine square z expansion is what? Sine square z expansion is z square is here. What is the next term? Z power 4. This is 6 means 3 minus z power 4 by 3. Next z power 5 is here. Z power 5 is there. 6 is here. What is this? Is 6. This is z power 6. 1 by 3 factorial. 636 this is. And plus, what about this one? 5 factorial. 5 factorial means 5 4 3 2. 5 4 3 2. 2 gets cancelled. So 20 23 is a 60. So 1 by 60 will be there. 1 by 60 will be there. So z power 6 both are. After simplifying, what is this one? This is nothing but what is the answer? 90 will be there. Yeah, 90. That is 2 by 45 z power 6 and so on. This is sine square z expansion. Now let me calculate numerator. Z square. What is the numerator? Z square plus sine square z. Z square plus sine square z is nothing but 2z square minus z power 4 by 3 plus 2 over 45 z power 6 and so on. Is it correct? Right? Okay. Now next step is what? 1 minus cos z. I have to calculate 1 minus cos z. Okay, let me write now the function z square plus sine square z by 1 minus cosine z. 1 minus cosine z. This is 2z square minus z power 4 by 3, 2 by 45 z power 6 and so on, whole by 1 minus cosine z. 1 minus z square by 2 factorial plus z power 4 by 4 factorial and so on. So what is this is? Let me take z square common in the numerator. This is 2 minus z square by 3 plus 2 by 45 z power 4 and so on. Whole by 1 gets cancelled. What is the denominator? If z square by 2 factorial minus z power 4 by 4 factorial and so on. Okay. Now take z square common in denominator also. Z square by 3 plus 2 by 45 z power 4 and so on. Okay. Divided by z square. Let me take z square by 2 common. So what is this? 1 minus z square by 4 factorial and 12. 12 means 6 will be there. Isn't it correct? Any corrections? Done. Z square by 2 is common. Then z square by 2 common means 4 3 is a 12. 24. 24 means 2 common. 12 will be there. Okay, and so on. Okay, if I want to write one more term here, z power 6 na. Z power 6 means what here? Z power 4 by 6 factorial. 2 common means 320 and so on. Now z square gets cancelled, right? So this is equal to 2 goes to numerator. 2 minus z square by 3 plus 2 by 45 z power 4 and so on, and take this to numerator. 1 minus, I will write this one in one bracket, z square by 12, minus is common, z power 4 by 316 and so on. This is in one bracket, whole power minus 1. Then this is 2 into, this part is as it is, plus 2 by 45 z power 4 and so on. What is this expansion? This is of the structure 1 minus x whole power minus 1. This is x value. This bracket is x value. So what is this is equivalent to what? 1 plus 1 minus x whole power expansion, 1 plus x square and so on. Okay. Using that formula, what is this? I will write only one term up to 1 plus x. So 1 plus x means what? This one. And so on. That's enough. Okay. For me, this is enough. Now, take the multiplication totally. This is what? This is 2 into, right up to some terms. 2 into 1, 2. Next. 2 into this one. That is plus z square by 6 will be there. Done? Right. Next one. I will write up to z square only. Okay. Next one, z square into z square by 3. This is minus. This is minus z square by 3. Is it correct? Right. This is 2 into this, 2 into this. Next one, z power 4. Next term is z power 4. So I can write this is order of z power 4. Order of z power 4 terms. That means order of z power 4 means which contains z to the power of 4 terms. Minimum degree. Minimum degree of the deleted terms is z power 4. So 2, this is 6 LCM minus. So minus z square by 6 you will get plus order of z power 4. Order of z power 4. Therefore, what is the expansion? F of z equal to 4 minus z square by 3 plus order of z power 4 is the Taylor series expansion. Is the Taylor series expansion. When we have to follow this procedure, when the point is given, na, if I substitute that point in the function and it has 0 by 0 form, then you can utilize the Taylor series expansions of the known functions in the given function. That is sin z, cos z. I have utilized that. And to find the radius of convergence. To find the radius of convergence. Here, now see, this is, I'm not applying any formula because I don't know what is the nth term here. Say to find the radius of convergence, I must know nth term. Then what is the L formula? Limit n tends to infinity, modulus of an plus 1 by an. Then R value is 1 by L. That decides the radius of convergence, R. Here, f of z is what function? Z square plus sine square z by 1 minus cosine z. 1 minus cosine z. Clearly, see, I'm finding in another way. Clearly, f of z is not analytic. F of z is not analytic. At what point? At 1 minus cosine z equal to 0. At 1 minus cosine z equal to 0. So cosine z equal to 1. When this cosine z equal to 1, that is cosine z equal to what values? 0 plus or minus, what is the value? Positive 1, na? Positive 1 means even pi, plus or minus 2 pi, plus or minus 4 pi, and so on. That is, what is the generalization? Cosine z equal to plus or minus 2 n pi. N belongs to z. N belongs to z. Are the singularities. Are the singularities. Where the function is not analytic. Or the singularities. Okay. That is, now understand this concept. That is, f of z is not analytic. Not analytic. At z equal to 0, z equal to plus or minus 2 pi, z equal to plus or minus 4 pi, and so on. These values are there. Now, where is z equal to 0? See, this is z equal to 0. And we are finding this is the center. I already told you what is this is Taylor series about point z equal to z0 means this is called center. And within what radius? This is, if I take 2 pi, for example, assume this is 2 pi and this is minus 2 pi. Which point is at a least distance? 2 pi is the least distance. Next one is what? 4 pi. So what is the radius up to within this radius less than 2 pi, that is f of z is analytic or convergent. F of z is analytic or convergent within the radius, within the least radius, you say, within the least radius 2 pi. Is it correct? That means if I construct a circle with radius 2 pi, at 2 pi it is not analytic, but within 2 pi it is analytic. Within 2 pi it is analytic. Okay, got it? Within 2 pi it is analytic. Therefore, f of z is analytic or convergent within the least radius 2 pi. Therefore, radius of convergence, this is another way of finding. Radius of convergence is r equal to 2 pi. And what is the circle of convergence? Circle of convergence is what is z minus z naught less than r. Okay, that means what? Z minus 0 less than 2 pi. Mod z less than 2 pi. Within this circle, this is the circle of convergence. Okay, r equal to 2 pi. Any doubts in this question? I'm applying a different way to find the Taylor. Actually, Taylor series formula, you know what is the Taylor series formula about a point. But I am using expansions directly. Next one.
Sir, here at z equal to 0, it is not analytic, no?
Which one? Z equal to?
0.
Z equal to 0?
Not analytic, right? But you wrote f of z is analytic within the radius 2 pi.
Within the radius 2. See, at z equal to 0, it is not analytic. At z equal to 0, it is not analytic. But 0 to 2 pi, in between 0 to 2 pi, in between 0 to 2 pi, is it analytic?
Yes, sir.
Yes, that means what? The radius which is less than 2 pi, the function is analytic, means convergent. Got it? So I am selecting only the least radius.
Okay, sir.
Okay, got it? Right. Now obtain the Taylor series of principal logarithmic function. Logarithm function. This is solved problem in textbook. So assignment, this is f of z equal to ln z, standard function ln z. Ln z about ln z means log z to the base e about the point z equal to -1 plus I. Obtain its radius of convergence. Obtain its radius of convergence. Okay, for your idea, I'm giving ln z means log z to the base e. Log z to the base e. Now, you know the Taylor series expansion? Yes. Next one. Yeah, take these problems. If you want anyone, you can ask. I will tell. Obtain first obtain about the point z equal to 0 is given. Okay, directly I'm giving. Obtain Taylor series of first question. F of z equal to sine z about z equal to pi, about z not pi. Okay, I can take about z equal to pi, that's enough. Okay, second one, f of z equal to f of z equal to 1 by 2z plus z square about z equal to 1. You know the formula about a point, Taylor series formula. Okay. Third one, f of z equal to tan z. About z equal to 0 means Taylor's Maclaurin series. F of z equal to e to the power of z cosine z. About z equal to 0. Just I am giving hint here. Taylor series about z equal to z naught is f of z equal to what? First f of z naught plus z minus z naught into f dash z naught plus z minus z naught whole square by factorial to f double dash z naught and so on. F double dash z naught and so on. Okay, just you find f of z naught, f dash z naught, f double dash, f triple dash, and substitute in this expansion, you will get the result. Okay, and the next topic is the most important one, Laurent series. Laurent series. Laurent series. This is N. Laurent series. Series statement of the Laurent series. Let a function f of z. Let a function, complex function f of z be analytic. Be analytic inside. Be analytic inside the annulus. Inside the annulus, in bracket, annulus means ring shaped region. Annulus means ring shaped region. Ring shaped means your ring. Okay. Ring shaped region means it is bounded by two concentric circles. Bounded by two concentric circles. Ring shaped region. Small r less than z minus z naught less than capital R. Means what? It is a circle with a radius with center at z naught. Okay, and radius greater than small r and less than capital R, and on the boundary, and on the boundary, and on the boundary, you write on the bounding circles, and the bounding circles. What is the first circle? Circle C1. Mod z minus z naught equal to small r, and second circle C2, mod z minus z naught equal to capital R. Capital R. First assumption is what? The function f of z is analytic in a ring shaped region. Analytic in a ring shaped region bounded by two concentric circles having center at z naught with radius small r and capital R. Okay, and on the circles also, bounding circles. Then f of z can be represented by, f of z can be represented by the Laurent series. Now this is different. Taylor series is over. Represented by the Laurent series as f of z equal to C naught plus C1 into z minus z naught plus C2 into z minus z naught. Okay, let me write again your, like, don't talk, a naught, a1, a2, a naught, a1, a2 into z minus z naught whole square and so on. Up to this, what is this one? F of z equal to a naught plus a1 z minus z naught, a2 z minus z naught whole square. What is this one? Taylor series, you know, right? Taylor series where an equal to what? 1 by n factorial nth derivative at z naught. Here, after these positive powers, after this, all these are positive powers, there will be one negative power, a minus 1 by z minus z naught, a minus 2 by z minus z naught whole square. Okay, next a minus 3 by z minus z naught whole cube and so on. Negative powers are also there. What is the meaning of this? Okay, that means I can write this series, power series, as First one power series is what? N equals 0 to infinity an z minus z naught whole to the power of n. Agreed? First one positive power series. Plus coming to negative power series, it is started with 1. So 1 to infinity, I will write like this. A minus n z minus z naught whole to the power of minus n whole to the power of minus n. This is called Laurent series. This is called Laurent series. One can write this one as otherwise, or you can write like this also. See, 0 to infinity is there, and next one, so minus 1, everything is there now. Shall I write like this? Minus infinity to infinity an z minus z naught whole to the power of n. Correct? Complete. Negative powers are there, positive powers are there. Negative powers are there, and positive powers are there. Right? Okay. Here, where now this is important. Don't forget this formula. Where an, what is an? The quotient. In Taylor series, what is the an formula? 1 by n factorial and the derivative at z naught. Now in Laurent series, an formula is 1 by 2 pi I integral over gamma. 1 by 2 pi I integral over, I can take gamma y c. C1, C2 have taken now. C, f of some, you take instead of, okay, I will take xi. Instead of z, I will take xi. F of xi by xi minus a. Xi minus a. A not a. Here, what is our z naught is there? Here, z naught. Xi minus z naught. T xi. And this power n plus 1. Power n plus 1. Okay. Okay. The same formula for this is true for all n. If I want to write for a minus n, just replace n by minus. That's it. F of xi by xi minus z naught whole to the power of minus n plus 1 d xi. So you remember one formula. That's enough. You remember one formula. This is enough. An formula, this one, this is positive powers, negative powers. Or if you want to remember this formula, this is enough. You can write for all n. For all n belongs to z. For all n belongs to z. Got it? Tell once again. Let me explain what are the conditions in Laurent series. This is z naught. Done. And this is one radius r, small r. One circle is here, and with radius capital R. This is capital R radius with some capital R radius. This is one circle. Okay, this circle is what? C2 now. This outer circle C2, and with a small radius R, C1. Okay, so where is the region here? This is the region, ring shaped region. This is the ring. Annulus, this is called annulus. This is my domain, ring shaped region. Okay, this is what? R less than mod z minus z naught less than R, ring shaped region. And in this ring shaped region, what I'm considering? One curve. This is one curve. This is C, which lies inside the domain, which lies inside the domain. Then what is this? F of z can be expressed as positive power series. Exactly this. Summation an into z minus z naught whole power n, and then negative power series, positive power series and negative power series. Okay, clearly. Now see the points here. Clearly, f of z is analytic. F of z is analytic only in the ring shaped region. Only in the ring shaped region. But not at z equal to z naught. Remember this point. At z equal z naught, where is this point? It will not belongs to ring shaped region. Remember, but not at z. If at z equal to z naught, see, if I take z naught, this an will not be defined. An, a minus n will not be defined. Okay, so f of z is not analytic at z equal to z naught. For example, if f of z is analytic, f of z is analytic everywhere, f of z is analytic everywhere at z equal to z naught also, then what happened? Everywhere analytic means what? There is no concept of ring shaped region. There is no concept of ring shaped region. It is also analytic everywhere. And then this a minus n will be 0. A minus n will be 0. Then, therefore, then Laurent series becomes what? Laurent series becomes what? Laurent series becomes Taylor series. Only positive powers are there. Therefore, in the series, only positive powers are there. Therefore, Laurent series becomes Taylor series. This is one important point. And next one, that is okay. Then, what this happens? General formula using Cauchy integral theorem. You can write what is then. See, what is an formula? 1 by 2 pi I integral over c f of z by z minus z naught whole power n plus 1 dz. Correct? This is an formula. Okay, I'm talking about when this case up, when f of z is analytic everywhere, then what is an? Am negative, n is always 0. But what happened to an? Using now an formula is this one, using Cauchy integral formula. Using Cauchy integral formula for derivatives. For derivatives, we have, what is this expression? We have integral over c f of z by z minus a whole power n plus 1 dz. What is this value? Do you remember? Anyone? This is n plus 1 means nth derivative will be there. Right? This 1 by 2 pi I. Nth derivative n factorial will be there by n factorial. Therefore, n factorial. This is Cauchy integral formula for derivatives. Therefore, what is this an value? Exactly this. Therefore, an equal to 1 by n factorial fna, which is exactly Taylor's theorem. In Taylor's theorem, what is the an formula? Exactly this, which is the value of an in Taylor series. In Taylor series. So remember, if the function f of z is analytic everywhere inside the circle C2, then a negative, a minus n value 0. There is no question of Laurent series. Only positive powers will exist, and that gives Taylor series expansion. Taylor series expansion. Now, I will tell one problem based on combinedly Taylor series, and first thing, I will tell one easiest problem. Yeah, see. Question is, find not like this. It's a very big one. Okay, let me tell you one small one. Expand or find. You write expand, that's better. I will tell one small problem today. F of z equal to 1 by z minus 1 into z minus 2 in the region A, mod z less than 1, B, 1 less than mod z less than 2, C, mod z greater than 2, D, 0 less than mod z minus 1 less than 1, mod z minus 1 less than 1. If you understand this problem, everything will be clear when we get Taylor series, when we get Laurent series expansion. First thing, f of z equal to 1 by z minus 1 into z minus 2. Find the partial fractions for this. It's compulsory. So 1 by z minus 2 I will write. 1 by z minus 1. Check it. Z minus 2 means minus z plus 2. Yeah, 1 by. This is correct, right? Partial fractions are over, right? First question. What is the reason is mod z less than 1. Mod z less than 1. Okay. Catch the logics for the expansions. That is very important. Mod z less than 1. Mod z less than 1 means this is the circle of convergence with radius less than 1. When mod z less than 1, that means what are the related terms here? Z and 1. Z and 1. Z and 1 are here. So for the second term, there is no problem for the expansion. But for the first term, z and 2, when mod z less than 1, what is mod z by 2 less than 1 by 2? Agreed? And 1 by 2 is less than 1? Yes. Therefore, mod z by 2 is also less than 1. So, 1 is mod z less than 1. This is for the second term. And the mod z by 2 is for the first term. Therefore, f of z, how to modify this f of z? Z minus 2 minus z minus 1. Z minus 2 minus z minus 1. So, I have to, in the first term, I have to get z by 2 terms. Therefore, take 2 common, minus 2 common, 1 minus z by 2. I have to get z by 2 terms, compulsory. See, always remember, all of you, the expansion 1 plus x whole power n, expansion so and so, is possible when mod x is less than 1. This value, this mod x value is less than 1. That is the reason of convergence. Mod x less than 1. The series expansion is possible. So I am converting to this structure 1 minus x. What is this? Mod x must be less than 1. Since mod x less than 1, I can expand this using binomial series, right? Now, what is this one? Mod z less than 1. So I have to take minus 1 common here. I will write 1 minus z. So get these terms. The important is for this z by 2 term and this z term. Z by 2 term and z term. So I will write once again minus 1 by 2 into 1 minus z by 2, where z by 2 less than 1. This is plus 1 by 1 minus z, where this z is less than 1 and z by 2 is also less than 1. So I can expand this. So minus 1 by 2, 1 minus z by 2 whole power minus 1 and 1 minus z whole power minus 1. Okay. So what is the expansion now? Minus 1 by 2, 1 minus x whole power minus 1, 1 plus x square plus x cube and so on. This is the first one. And next one is what? Plus, this is 1 plus z square plus z cube and so on. This is the second one. Let us combine the similar terms. This is minus 1 by 2 plus 1 by 2. Coming to z terms, what? For the z terms, z is common. I am taking this is 1 minus 1 by 4. Next one I will take z square term common, 1 minus 1 by 8. Next one z cube term common, 1 minus 1 by 16. 1 minus 1 by 16, right? And so on. So what is this becomes? This is equal to 1 by 2. This is f of z. What is this? Plus 3 by 4 z. Next plus 7 by 8 z square plus 15 by 16 z cube. What is the series? Is a series of positive powers, right? Series of positive powers in z. Nothing but a naught. I will explain. This is a naught, a1z, a2z square, a3z cube. Nothing but what is the series? Therefore, it is a Taylor series expansion. It is a Taylor series expansion. Okay, this is the first case. And what is the logic is what? This is main important. Okay, after getting partial fractions, I know mod z less than 1. Mod z less than 1 means just write this as 1 minus z, second term, 1 minus z. but this first term is having terms z and 2. So get z in 2 terms in this one. Mod z less than 1 means mod z by 2 less than 1 by 2. So mod z by 2 less than 1. So here take minus 2 common to take z by 2 terms in the first one. So I'm taking minus 2 common, getting z by 2 terms. Therefore, expansion is possible. This expansion is possible because mod z by 2 less than 1 and mod z less than 1. Okay, and simplification. Coming to second one. What is the reason is? What is the reason? 1 less than mod z less than 2. So clearly, what is this reason? Clearly, z equal to 0 and a 1. So this is one circle. This is 2. Take this as 2. This is another circle. Where is the z lies between? 1 and 2 means what? Exactly this one. So ring shaped region. This is what? Ring shaped region. This is ring shaped region. So analyze. So which series you will get? Definitely Laurent series expansion. Laurent series expansion. Now see, what is f of z? 1 by z minus 2, z minus 1. Please understand the concept. This one. We have 1 less than mod z less than 2. This is important. If you are thorough with this, everything will be clear. That is one thing. 1 less than mod z and a mod z less than 2. Agreed? Please answer. 1 less than mod z and mod z less than 2. Agreed?
Yes, sir.
Right. Now, see, for the expansion, what I need always, remember, for the expansion, expansion, we require something, some function of z less than 1. Some function of z less than 1. This implies, what is this? Mod z is greater than 1 and a mod z is less than 2. Right? But I have to get what? Less than symbol compulsory. Some function of z. This is some function of z. Some function of z less than 1. So see, this is greater than 1. I will convert to less than 1 by taking 1 by mod z. Correct? Reverse it. 1 by mod z less than 1. And here, since in the first term, what are the terms? Z and 2 are there. So corresponding relation is mod z by 2 less than 1. Take 2 this side. Take 2 this side. Now, according to these inequalities, I have to change the function. I have to change the function. What is this function? This is the function. In the first term, z and 2 terms are there, z and 2. So I have to get z by 2 term. So I will take minus 2 common. Z by 2 I'm getting. Clear? Right? But z and 1, what are this relation between z and 1? It is 1 by z. So in the second term, I have to take z common. I have to take z common. 1 minus 1 by z. I will get 1 by z term here and z by 2 term here. Now expansion is possible. Why? Because this z by 2 is mod z by 2 is less than 1. This is 1 by z and mod 1 by z is less than 1. Now apply the formula. Minus 1 by 2. This is 1 minus x whole power minus 1. 1 plus x square plus x cube and so on. This is over. Minus 1 by z. This is also same. 1 plus x square plus x cube and so on. Now let me simplify. This f of z is equal to minus 1 by 2 minus z by 4 minus z square by 8 minus z cube by 16 and so on. Coming to this part, minus 1 by z minus 1 by z square minus 1 by z cube and so on. So what are these? See, let me compare this. I will write just one thing. This is what? A0, A1z, A2z square and so on. Coming to here, what is here? I will write quotient as negative, A1 by z. A1 by z means what? Negative power. A minus 2 I will write z power minus 2. A minus 3 I will write z power minus 3. Negative powers are there. So I can write this as f of z equal to minus 1 by 2 minus z by 4 z square by 8, z cube by 16, and so on, minus z power minus 1, z power minus 2, z power minus 3, and so on, which is clearly positive and negative powers are there, which is positive and negative powers means what is the series? Which is Laurent series expansion. Which is Laurent series expansion. Any doubts? So always remember the conversion of the terms is very, very important. Z minus 2, Z minus 1, how they can be altered according to this relation, according to this inequality. Now, coming to third one. What is the third one? Reason is what? Mod Z greater than 2. Reason is mod Z greater than 2. Remember, mod Z greater than 2. Since mod Z is greater than 2, what I have, take this Z on the right side. 2 by Z is less than 1, agreed? 2 by Z less than 1, or you can write 1 by mod Z less than 1 by 2. 1 by mod Z less than 1 by 2, correct? Less than 1 by 2. That implies 2 by Z less than 1. Now this is my relation. I have to get 2 by Z terms and one more. And 2 by Z less than 1 implies, what is 1 by Z? Implies 1 by Z is what? Less than, that means divided by 2 on both sides. Less than 1. That means what? 1 by Z less than 1. This is another relation. Because in f of Z, I have two terms. One is Z minus 2. Another one is Z minus 1. I have to get relation between Z and 2 and Z and 1. So one is 2 by Z. Another one is 1 by Z. Any doubts? Any doubts? 2 by Z less than 1. Dividing on both sides by 2. 1 by Z less than 1 by 2. That is less than 1. So 1 by Z. So I have to get what terms? I have to alter this one as what? Take Z common. 1 minus 2 by Z I am getting here. Next one. Take Z common. 1 minus 1 by Z I am getting here. So what are the terms now? 2 by Z, 1 by Z. What are these? 2. Less than 1, less than 1. So expansion is possible. So expansion is possible. So this is 1 by Z. 1 minus 2 by Z whole power minus 1. 1 by Z. 1 minus 1 by Z whole power minus 1. Right? So this is 1 by Z. Expansion is what? 1 plus 2 by Z plus 4 by Z square. Okay, I will end up this one. Minus 1 by Z. 1 plus 1 by Z plus 1 by Z square and so on. Now let me simplify this. 1 by Z plus 2 by Z square plus 4 by Z cube and so on. Next minus 1 by Z minus 1 by Z square minus 1 by Z cube and so on. So this first term gets cancelled. What is this? 1 by Z square. This f of Z is equal to 1 by Z square. This is what? Plus 3 by Z cube, right? And so on. That means what? Any positive power is there? All of you. Z power minus 2, 3Z power minus 3 and so on. Which is, it is not Taylor series. So definitely, which is Laurent series. Which is Laurent series expansion. Why this is, why we are getting only negative powers? Because of the region. What is the region? All of you observe this. Mod Z greater than 2. 2. This is with radius 2. Let us draw one circle. This is 2. Okay. Mod Z greater than 2 means where is the region? Outside. Mod Z greater than 2 means what? This is mod Z greater than 2. Region. Infinity. Up to infinity. Where is the upper circle? Where is the another circle? Long circle with radius infinity at infinity level. That means mod Z greater than 2 here. Mod Z greater than 2 is also a ring shaped region. Ring shaped region bounded by mod Z equal to 2 and another one is what? Mod Z is infinity. Mod Z is infinity. When such case, when mod Z greater than 2, only greater than symbol is given, then definitely you will get negative powers only. negative powers only. Got it? Ring shaped region bounded by mod z equal to 2, and another circle is at infinity level. At infinity level. Any doubts? Any doubts? And the last one, region is what? 0 less than mod z minus 1 less than 1. What is the change here? Mod z minus 1 less than 1. What is the change here? This is the region. This is the region bounded by the circle. Bounded by the circle with center at what? With center at 1. Z equal to 1. And radius? What is the radius? Radius also 1 unit. Okay, with radius 1 unit. Okay, but what is the function here? So let whenever this type of thing is here, not z, in between not z, it is z minus 1. Put z minus 1 equal to u. Then what is z equal to u plus 1? U plus 1. Then region becomes, just I am simplifying the problem, that's it. Region becomes 0 less than mod u less than 1. 0 less than mod u less than 1. Nothing but what region? What region? Point circle. Point circle with radius less than 1. With radius less than 1. Only inside. Only complete inside. See what you will get here. Now what is f of z here? 1 by z minus 2, 1 by z minus 1. So I have to substitute z. U plus 1, that is u minus 1. This is minus 1 by u. 1 by u. Okay. Here I will write at side. Mod u is less than 1. There is no question about mod u greater than 0. Nothing but it is a circle having radius greater than 0. Okay. Mod u less than means u and 1. Mod u less than means I have to convert, I have to take minus common. That's it. So 1 minus u. There is no expansion for 1 by u as it is. That is equal to minus 1 minus u whole to the power of minus 1, 1 by u. So minus 1 plus u square plus u cube and so on, minus 1 by u. Minus 1 by u. So minus 1 f of z expansion minus u square minus u cube minus 1 by u. Now substitute u value. What is u? Minus 1, z minus 1, z minus 1 whole square, z minus 1 whole cube and so on, minus 1 by z minus 1. Minus 1 by z minus 1. That is nothing but what? Minus 1, z minus 1, z minus 1 whole square and so on, minus only one negative power is there. Positive powers are infinite, negative power is only one, is the Laurent series expansion. Since positive and negative terms are there, Laurent series expansion of f of z about what point? Clearly it is given. What is the point? 1. About z equal to 1. About z equal to 1. This is complete picture of Laurent series. How to expand any function. How to expand any, where is that? How to expand any function using Laurent series expansion. Any doubts? Yes. Now class is open for discussion. Any doubts? Definitely one question will be there in Taylor's and Laurent series expansions like this problem. Is it clear?
Yes, sir.